Our next video is going to be a review of our favorite thing, and I mean that sarcastically, factoring. So what I'm going to do in this video is I'm going to go through factoring ax squared plus bx plus c, which is our typical trinomial form when a is equal to 1. Now there is a shortcut for solving these problems, but for the sake of making sure the harder problems are a little bit easier, I'm actually going to go through step by step. Before we do that though, I do want to talk about what I mean by ax squared plus bx plus c. This is the standard form of a trinomial. Just like you have standard form of linear equations, this is the standard form we use. Just wanted to make sure you understood when I speak about using the a, the b, or the c. In this trinomial down here, the a is 5, the b is 2, and the c is 12. Notice they're all positive because the numbers are either positive or there is a plus sign. In the next example, because there's no coefficient to x squared, a is just 1, b is negative 5, and c is negative 10. So throughout the video and the next video we have, anytime you hear me say a, b, or c, I just wanted to make sure you understood what I was referring to. Example 1. Now for this example, I actually took the time to kind of write out all of the steps. If you would like to write those down, I would suggest you pause the video right now and just make sure that's okay. So for our first example, we're using x squared minus 13x plus 36. I decided not to start with one where all of the coefficients were positive because those are the easiest to solve. So if we're not doing the shortcut, these are the steps that you would do. The first thing you would do is multiply a and c. In this trinomial, a is 1, so that makes it pretty simple. We're just going to multiply 1 times the c, and we get 36. So next what you want to ask yourself is what numbers multiply to give you ac, but add to give you b. We already know ac is 36, and we need to get b. In this problem, b is negative 13. Because the b is negative, that means both numbers must be negative to multiply to get to 36. This is where it's just about mental math. It's just number sense. And just to show you that sometimes you don't always get the right answer the first time, I took it step by step. I started with negative 6 times negative 6. But when I added those up, that gave me negative 12, so that didn't really work. So I tried to pick two numbers that had a bit of a bigger gap, so I picked negative 12 and negative 3, and those also didn't work. It gave me negative 15, which was too big. Then I remembered I could do negative 9 and negative 4, and I actually got negative 13. Don't be afraid to sit there and try different numbers. Just try to find the ones that work, and it's okay if it's not right on the first try. Once we figured that out, we want to split up the polynomial and replace b. So what I'm going to do is I'm going to take out negative 13, and I'm going to put in these two numbers we figured out, which was negative 9 and negative 4. So this is what I did. I went ahead and I took out negative 13, and I put in negative 9 and negative 4. And I leave a little bit of a space there so that I know we're going to have two separate binomials to factor. Now with the factoring, we're going to look at each half and decide what can I factor out. Again, this is where if you were doing the shortcut, you could just go to the final answer, but I want to teach you the process for this video. In this first half, I see that both terms have an x in common, and in the second half, I see they have a 4 in common. Now, one thing I do notice about both halves is their signs are opposite. Let me explain what that means by showing you the next step. First thing, I noticed that I take out the x, I take out an x from each of these, that means an x is left behind, and minus 9 is left behind. Now I put a note here that what's in parentheses has to be the same. But when I look at what's in parentheses, and I look what's up here, the signs don't match. What that means is I actually need to take out a negative number from the second binomial. So I take out a negative 4. And I notice that both of these match. To get to our final answer, all we want to do is put together what's in front of the matching parentheses, so that's x minus 4, and then I list what they have in common. Now step 4 I didn't type each time because a lot of us can probably do this in our head, but I would double check and use FOIL to make sure the steps work. Now if you were doing the shortcut, you would do step 1, step 2, and go right to the end. It's perfectly okay to do the shortcut when you don't have a coefficient that's not 1. I'm sorry, excuse me, a coefficient of 1. That's okay to do the shortcut, but I do want to show you the steps. Example 2. I have x squared minus 7x minus 60. Throughout these videos, if you actually want to stop and see if you can solve ahead of me, that's perfectly okay. You do whatever you think is comfortable. So for step 1, multiply AC. That hasn't changed. So A is 1, C is negative 60. I'm going to do 1 times negative 60. Now I notice that my C is negative and my B is negative. That tells me that one number has to be positive and one number has to be negative. And if B is negative, the bigger number is going to be negative as well. So I did the same thing. I went through and I started with some easy ones. I did 6 and negative 10 or negative 6 and 10. And it was close, but I still didn't get negative 7. That didn't work out. Then I tried 12 and negative 5 or negative 12 and 5, and I noticed I did get a negative 7 if I chose these two. Again, it's really just a number game. If you can go through and make the numbers that work out, then you don't have to try as many numbers as I did. Next step, take out the B. I take out negative 7, I put in its place negative 12 and a positive 5. Just like before, we want to separate the two binomials. So we have x squared minus 12x to the left and 5x minus 60 to the right. So we clearly always take out an x in this one, and we're going to take out a number here. What's nice this time, and I'll just show you how I factored it, is I didn't have to take out a negative because these two matched. And just like before, we put the numbers in front of the parentheses together, and I list what they have in common as well. For our next example, we're going to go back to something we saw in the final where a trinomial actually equals 0. So I'm going to actually ask you if you could pause the video and do step 1 all by yourself. I just want you to factor this piece, not the equals 0, but just that piece. And in about 10 seconds, I'm going to reveal the answer. Here's the answer to the factoring. What I wanted to show you is because I let you solve on your own, you may have your numbers in a different order. And I wanted to show you it doesn't matter what order you put in what you replace B with. I still get the same answer in the end because in multiplying, it doesn't matter what order they're in because of the commutative property. Now, you've got two binomials, x minus 3 and x plus 8. We've talked about the 0 principle before. If these two numbers multiply and equal 0, that means at least one of the equations has to solve for 0. So I wrote each equation separate. To solve this one, to get x isolated, I'd have to add 3. To get x isolated, I had to subtract 8. When I do that, I get that the values are 3 and negative 8. Now that we're back into algebra world, more than likely there will be two answers for each quadratic equation, which is what this is technically called, that we are factoring. But there are chances where there might just be one or there might be none. To change our your turn now, I'm actually going to show you the answer in our video. So let me show you the problem, and in about 5 seconds I'm going to show you the answer.